Hi everyone, I'm Kavita Parihar, Director of Technology and Cox Edge, and welcome to the October episode of our monthly webinar series, The Future of Edge. In this series, we ask questions about what the future will look like 6 to 12 months from now in the world of edge cloud and cloud computing. There are many types of storage technologies and differences in how they are designed, interconnected, and consumed. Today, we are digging into something that everyone who has been developing on cloud has dealt with, object storage. Like other type of storage, object storage has its own unique characteristics, and without many people noticing, object storage has changed a lot recently, especially the fast object storage. To help us understand what's different, what's possible that wasn't possible before, and what we can expect to deal with, we have invited one of our the best thinker in this field, Justin Emerson from Pure, to talk to us. Hi, Justin. It's great to have you here. Can you tell everyone about yourself and Pure?
Hi, Kavita. Thanks very much for having me. So my name is Justin Emerson. I'm a technology evangelist for PureStorage. PureStorage is a industry-leading enterprise and cloud storage player. Just recently, we were named a leader in the Gartner Magic Quadrant for the 9th year in a row. So we're very excited to be here. Thank you for having me.
Awesome, awesome. I have been looking forward to this chat for a while now, and I have a lot of questions queued up and ready to go. But let's start at a very high level and drill down. What is object storage, and why should people care about it?
Yes, great question to start with. So object storage really is a new paradigm of storage. So if we think about before, there were block and file, right? Block was a very low level kind of storage paradigm. File is a higher level abstraction. Object, in some ways, is an even higher level abstraction than that. So a lot of people used to use as an analogy, a file is like parking your car in a parking lot and having to remember, okay, I'm on this floor in this block going, and I need to make sure I take this elevator to get there, right? I have to be able to navigate my way to that file. Object storage is more like a giant valet where you take your data, you say, I want to park this data here, and then it returns a ticket for you. And anytime you want that data back, you go and give that ticket, and then you get that data back. So the way that the data is organized and placed is all sort of abstracted away from the end user. And this has been really useful in large cloud native environments where massive scale makes a lot of those organizational boundaries and so forth very difficult to maintain and create a lot of complexity. And so object storage is really designed to get away from that. Its other big thing, and this depends on the kind of object protocol, but in general, most object protocols also ride on top of very standard internet protocols, such as HTTP, the same thing that your web browser uses. And they'll use what we call REST APIs, which are very, standardized, simple to use programmability interfaces, which makes object storage ideally suited for applications to interface directly with storage rather than, say, for example, a user to interact with storage. So a lot of cloud native applications or cloud native services are built around object storage because of its scale, its portability, and its interoperability, and its programmability.
Awesome, awesome. Well, everyone thinks, object storage is slow and static, and you are saying that's changing. What's involved in making object storage fluid?
Right. So I think for a lot of folks, when they think about object storage for on-premises, they think about, a backup target or a cheap and deep or a geographically distributed bunch of spinning hard drives, right? In the cloud, that's very different. So in a public cloud or in a shared private cloud infrastructure, object storage is just another protocol. It's just another paradigm. It's not a tier of storage. Within, for example, Amazon, there's multiple different tiers of object storage, all the way down to Glacier, which we all speculate is probably just living on tape somewhere.
Yeah.
So object can be fast and it can be slow, but object itself is just a different way of interacting with storage and reading and writing data from it. So the reason I like to say it's can be fast and fluid is because object is so portable. Because object gets rid of some of the things in sort of the file paradigm that are very difficult to scale, across multiple geographies. For example, in object storage, an object, which is sort of the atomic unit, right? You, instead of a file, you have an object. That's the smallest unit that you can write. An object is immutable. You can't actually change it. You can write a new object, or you can write a new version of an object. This makes doing things across geographic distances much easier. It also makes it so that you can have models that are eventually consistent. In other words, I may get a different result depending on when I read it, because it'll eventually be consistent, or immediately or strongly consistent, where as soon as I write it, I know it's going to be the exact thing that I just wrote. So it's got a lot more flexibility in how it can be built. And so that provides a lot of opportunities for hybrid solutions, where you may have some things in the public cloud, some things in a private cloud, or some things in an edge cloud.
That's great, Justin. Okay, so then knowing that, why not just use cloud native storage like AWS or Azure? Or maybe when would it make sense to use AWS or Azure?
Right. In the hyperscaler cloud, so that's your Amazon, your Microsoft, Google, it's IBM, et cetera. All those public cloud providers, all of them have some kind of object store, and the reason they have that is it's the most cost-efficient, scalable way for them to provide storage, especially cross-region. If you are writing cloud-native applications, and those applications are running in those public clouds, depending on the data governance rules and so forth, it probably makes a lot of sense to have your data there. Moving data in and out of the public cloud providers can actually carry a cost, whether that's an egress charge or ongoing cost to have storage in the cloud. All those things are provided as a service, which means all of them carry a service cost. So if your application is running in the cloud and it's got data and it wants data close to it, right, from data locality standpoint, then it makes sense to have it there. So if you have a centralized workload, something where you're bringing all of your data into the cloud and then working on it there, then it makes sense to have all that data there. In fact, if you look at the hyperscalers broadly, they're kind of the largest storage companies now. They actually have more storage under management than almost any other private business. Where I think it makes sense to look at something else is not only in situations where, say, for example, you have a particular compliance or data governance concern, where maybe this is a data type that I can't have in a public cloud. Everyone always gets to see these news articles where some bucket was left anonymously accessible from the internet, and suddenly all this data's leaked out on the internet. But also there are situations where that data is stored on your local system, and you don't want to move all of that data up into the cloud. Like, say you have a hybrid workload, and I want to be able to do some processing in the cloud and some on premises. Moving all of that up into the cloud can be very time consuming and very expensive, and then getting out of that could be even more expensive. So that's where it starts to make sense to look at alternatives to storing stuff natively in the cloud providers. Hybrid workloads, ones that require more stringent data governance, or apps where latency really matters. So if you're in the cloud and you're only in the cloud, then your lowest latency option is going to be a storage in the cloud.
Yeah.
But if you have a distributed application or an on-premises application and latency matters to your application, then having your data in proximity to where your compute is and where the latency is at issue, that tends to be a better solution there. So there are good reasons to have storage in lots of different places, and that's why all these different solutions exist.
Right. And I'm going to mention here that egress can cost less with edge providers, right? So if you are one of those who are looking for lowering the cost, companies like Cox Edge can be a great option. Okay, so interesting. I knew I was going to enjoy this talk. So say, for example, if I'm a developer, which I was once upon a time, or a solution architect, what are some of the common example or application or use cases for object storage? What can I do now that I couldn't do before?
So I think broadly, there isn't necessarily just a one set of applications that object storage is suitable for. I think object storage is going to become more relevant over time as more applications get rewritten to use object storage. And why would they want to do that? Because many legacy applications and as well as new applications are all being written with these cloud native semantics in mind. So if you have a traditional application and you want to make it more economical to run your application in the public cloud, then you want to think about how can I refactor or re-architect my application in order to be more cost effective there to let my customers run it in the cloud more effectively. We see this in a lot of different, say, for example, analytics tools, whether that's, your Splunk, Elastic, Vertica, and then even things like things you would traditionally expect to be block workloads are starting to look at, well, using block in the cloud may be less elegant than using objects. So how do I rework that? I think if we think about things that are possible now with, for example, with edge computing, I think of things like distributed applications or maybe sort of Internet of Things applications. So let's say you're a municipality or you're a private company with a lot of sensors. And what you want to do is you want to build in analytics that analyze the data from those sensors, but you have a particular latency sensitive activity you want to notice. If somebody, say, for example, breaking and entering, you want to know that as soon as possible. So having that analytics closer to the source of your data is going to give you a faster time to value on that data, if that's the way you look at it. So maybe something like an IoT workload where edge starts to really matter. Data pipeline. So let's say you have that same sensor network, but you are filtering down a large chunk of data before forwarding that on to where you're doing your final processing. Let's say, most data pipelines involve not just collecting the data, but also cleaning the data, pruning the data, sometimes, reformatting or making modifications to it, ETL workloads kind of stuff. And then maybe they'll go into some sort of machine learning pipeline where you take that data and you use it to improve a machine learning model. And so all of these things require high performance if you want to do them in a timely manner or a high performance manner. None of these are like, well, I'm just going to tuck this data away and hopefully never have to read it again. And so that means high performance object storage becomes not only a nice to have, but a necessity for some of these workloads. And like I mentioned, depending on the kind of workload, having that flexibility to, say, scale up compute and storage independently, as opposed to the old way of doing it with big data or analytics, where you say, oh, I'm going to have a whole bunch of servers with a bunch of storage in them, and then I have to scale those all at once. Object storage, and especially object storage at the edge, can provide a lot of flexibility for how you design and architect these sort of data pipelines.
Right. Awesome. So I know a lot of our developer community deals with AI/ML workload, and storage solution that's high performance can really accelerate their dev cycle. We talked about the use cases for object storage. Are there any specific use cases that are not meant for object storage? What about database workloads?
Mm-hmm. Well, so interestingly enough, because the cloud, the public cloud providers are such a powerful force in sort of driving user behavior, mm-hmm. We actually see more and more workloads being redesigned for object storage, like I mentioned before. AI/ML is one of those areas specifically. So, for example, one of the most popular AI frameworks is called PyTorch, and PyTorch now has integrated into it S3 connectors. So in a PyTorch workbook, you can actually load object storage for your data set within the workbook without having to use a file system or file system semantics. It's really interesting, right? Why would you want to do that? Well, let's say you're running PyTorch in the public cloud. It's a lot easier to do that if you can just access object storage directly. No surprise, Amazon was one of the drivers behind getting that introduced into PyTorch. In terms of databases, I mentioned Vertica before, but Vertica is a scale-out analytics database, and originally they were built for a scale-out model where you have individual nodes, and each node has local storage. But they said, hey, we want customers to be able to run our solution in the public cloud, and so they refactored the back-end storage for that into something that they call Eon Mode. And Eon Mode was designed to run in the public cloud, but if you have on-premises object storage like Pure FlashBlade, you can, one of our customers, our mutual customers with Vertica said, can we run this Eon mode thing, but on premises? And we tested it out and it worked really well. And so now we were the first storage vendor for certified for Eon mode with Vertica to come to market. And so even things that you would nominally think of as super high performance or very transactional, like a OLTP database, even those are starting to look at object storage, maybe not as like the top of the data pyramid, but certainly as part of sort of the data lifecycle that these applications go through.
Awesome. So one of the things I read was, if the data is not changing a lot, then object store is your answer, right? Because say, for example, if you're storing some kind of images, some kind of videos, and I think most of the streaming applications, they also use object store a lot. I'm not saying everyone is building applications like Netflix, but if you are working on something, most of the production houses, they use object storage a lot because where they can put all the video files, their videos to edit, they can consume from there, they can push it to another bucket called ingest, publish, and they can stream those video files from there. Awesome.
Yeah, CDN is a huge use case for object storage, content delivery networks. Object storage is sometimes called blob storage. And sometimes the reason people call it blob storage is because you just have these big blobs of data that you plop out there. Right. So it's a little crude, but that's kind of where that comes from, is the idea that you have these immutable objects, and these immutable objects can be any size. You can have a really big object, terabytes in size, just like you can have a multi-terabyte file. And you can also have, hundreds or thousands or millions or billions of very small objects. Maybe they're very small JPEGs, or maybe they're text files, or maybe they're bits of log files that you're ingesting, and you want to be able to, say, for example, index all of them without having to crawl through a file system with billions of files. I mentioned that object storage is kind of like a higher level abstraction than file. And I think there's a really great example that can illustrate that for listeners and viewers. If you list a bunch of files on a file system, the list command, whatever that is, returns all the files to you. So if you have a folder with 1 million files, you're going to be returned a list of 1 million files. And even if you're only looking for just for example, JPEGs, you have to get all 1 million of the files and then filter them yourself.
Right.
So the filtering happens client side. And that's because the file system has no context or no ability to say, do that filtering for you.
Yeah.
With object storage, it's in some ways more like a database. You can think of an object list command as kind of like in a SQL database doing a select group by, where you say, I want all of the objects that meet this criteria. And that filtration happens on the storage endpoint. So what you're doing is you're moving more of the storage management functions up into the storage layer as opposed to the client layer. And that's one of the ways that object storage can significantly scale significantly larger than a file alternative.
Got it. And Justin, so is that has to do with the metadata also, right? Because object, right? I mean, one of the attributes, one of the key characteristic of object is metadata, where you can not only say this object was created on this date, but you can have more attributes. And what you said, like a key value pair, you can say, okay, this was taken by this machine, or this was taken by all these. You can define, right? Which actually helps you for all these searches and for all these sorting and filtering happen very fast.
Right. And so objects can have custom metadata, they can have tags, they can have versions, right? We mentioned this briefly, but object storage in general has version control built into it. Whereas in a file system, how many times have we seen it's the PowerPoint final December whatever, right? It's the 3 different things appended to it. There's a lot of that stuff that's built into object storage specifically, including version control, which is really handy. And especially when, again, objects are supposed to be immutable. So rather than changing the object, you just write a new version to it, and then you can expire old versions by policy.
Right. So when we are defining the metadata, is there a specific standard that I, as an application developer, should follow? Or is it more of what is my application going to do? Like, I mean, how is my application going to access this object or going to perform any operation on those? Like, is there any standard which is defined for the metadata?
Well, so because object storage is sort of inherently designed to be application accessible, it really comes down to the application. I think broadly, if you want to think about like standards, most object stores are aligning towards the Amazon S3 API as a standard. Sort of, it's become, because it's openly published and it's well supported by the majority of the industry, it's sort of become the de facto object storage standard. Not that there aren't other object protocols out there, just like there's different file systems and file sharing protocols. But the standards seems to be coalescing around Amazon S3. And so the features that Amazon S3 has, things like tags, things like object metadata and versioning and so forth, are kind of the broad categories in which all of this metadata kind of sits. But there's not necessarily a big standard of, well, what tag should I use for this, or what object metadata tag should I use? That really comes down to what your particular application wants to use and what the needs of that application are. Because in general, it's better to think about object storage as something that applications interact with, as opposed to humans or individuals.
Yeah. Awesome. So, okay, so far we have talked about, what high performance object storage is and how it's not the sort of slow and static object storage we are all used to. We talked about object storage as a protocol, public cloud storage, and different use cases. How does Edge take advantage of fast object storage? Is there anything about Edge that is specially suited to fast object storage?
Well, so if you're thinking about writing applications that leverage Edge Cloud, you're probably thinking about writing cloud native applications or highly distributed applications that tend to follow those same kind of cloud native semantics. And therefore, you should be thinking about object storage because it is the most portable, it's the most cloud native kind of storage that you can implement for your applications. And so if you're building a highly distributed, high performance application where latency matters, then fast object storage matters. And where that fast object storage lives matters equally, because if your fast object storage is halfway across the world, you're not going to see that kind of performance because your lowest common denominator is going to be the speed of light. So where your Edge makes possible highly distributed, latency sensitive applications, and so that sort of unlocks a whole new category of the kinds of analytics pipelines and data pipelines that we can build.
Awesome. This has been so interesting. We had some questions submitted, so let's get into them. First up, someone asked, is object storage at the edge cheaper than cloud?
So I would say that highly depends, right? So object storage at the edge really is about enabling new kinds of applications or providing different capabilities than what the native solutions can provide. So like I said, if you're building an application that's a centralized application, you're running it in a public cloud provider, that's probably where you want your data to live, depending on how long it's going to be there and how much it costs and all those things, right? But if you are building one of these highly distributed or latency sensitive applications, then having high performance object storage closer to where the data processing is happening or where the data collection is happening, that is the critical thing. So I think it's less about a cost discussion than it is about a capability discussion, right? We don't talk about, well, is a car cheaper than a truck? Usually you're picking one or the other because you need the capabilities that it has, as opposed to just its ability as a people mover.
Right. I like that, though I would prefer everyone to use Edge, obviously, right? For
right.
So here's the second question. For object storage on-prem and private cloud, how can you get insight into capacity usage, how much is being consumed, bucket permission, etc.? Is there a tool or an API to manage object storage on FlashBlade?
That's a great question. So if you're used to managing storage that's a block storage or file storage, you're probably used to having to interface with some management user interface or command line interface in order to do things like make a new file system, make a new volume, take a snapshot, all these different things. And Pure FlashBlade, which is our unified fast file and object platform, which powers Cox Edge high performance object storage. We have that sort of management interface, but one of the really clever things about the S3 API being a higher level abstraction of storage is that it includes many of those management functions. So the ability to create a new bucket inside your little tenant, that's actually part of the S3 API spec. Being able to set a lifecycle policy on versions or objects themselves to say expire after a certain amount of time. Being able to do object lock where you prevent objects from being deleted. All of these things are part of the actual S3 API spec. So if you're a user or consumer of object storage, you can programmatically do all of these things in the same API context that you're reading and writing data from. So that's one of the, again, being a higher level abstraction, rather than having to use side channels in order to do all of these functions that block and file storage was never originally envisioned to have. All of these things are natively parts of the API for object storage in general. So that's one way that makes it easier to leverage, especially programmatically as part of your application.
Good points. Thank you, Justin. Thanks for being with us today. One of the key takeaways for me is that object storage is not equal to slow stores for backup and archives. It is possible to have a high performance object storage. Think about object stores as a different way of accessing an object where you read the whole object across the network. So you are going to be concerned about time to access the first byte of the object. How quickly can I get to it? And that's your latency. And then you are going to look at throughput. How quickly can I get the entire object stream to me? These are some of the important metrics to look for, and you can get object stores that are based off flash storage and therefore high performance. And I think with that, we will finish up. Folks, on the screen, you will see a link for Pure plus a QR code for Cox Edge. Pure has a great blog that covers most of the topics we discuss here today. And at coxedge.com, we have a link to a free developer trial. We'll send you an email in a few days with a link to the video and transcript for this episode. And we hope you will join us for the next month's session too. I'm Kavita. Thanks again, Justin, and everyone who tuned into this webinar. And we hope to see you next month. Bye.
Thanks. It was great being here. Thank you.
Thank you.